Hello my dear all students, have a nice day. By this video I am going to discuss about in your combined mathematics 2 paper, that means applied paper, question number 14 part B. So question number 14 belongs to vectors and coplanar forces. Vectors and coplanar forces. So especially there are two sections, part A belongs to vector part and part B belongs to coplanar forces. But there can be a single question that both combine with vectors and coplanar forces. As we know, a force, it is a vector. Therefore, every vector relations are applicable with these forces. Every vector relations are applicable with these forces. Therefore, you have a good idea about vectors first. So, in your question number 14, so there will be a system of coplanar forces. That means all forces are act along a same plane. All forces are act along a same plane. So that is we call coplanar system of forces. These forces can be concurrent or not. Concurrent means meet at same point. Then these forces can be concurrent or not. So usually in this question, forces given concurrent only. All forces given only coplanar. Coplanar. Sometimes that can be concurrent, sometimes that can be non-concurrent, but usually they are given non-concurrent forces. Okay. Then the ultimate target of this question, we have to deal with three segments of the system. So one thing, so here the system of coplanar forces can be reduced to a single force. That system of forces can be reduced to a single force. That single force we introduce as a resultant. Therefore, if a system of forces given, if it is equivalent to a single force, so we call that as resultant. That resultant we can find by resolving forces horizontally and vertically. Horizontally and vertically. Take x component and y component by resolving all the forces. Then get algebraic sum. Then we know x and y component of the resultant. Then by using that you can find the magnitude of the resultant and the direction of the resultant. We say magnitude of the resultant x squared plus y square root, and the direction of the resultant tan inverse y divided by x. Tan inverse y divided by x. The resultant magnitude and direction. So if the system equivalent to a single force, we have to know how to find its line of action. We know how to find its line of action. By taking moments, we can find the line of action. The line of action. So now the system of forces is equivalent to a single force now. Therefore, system equal to single force. Therefore, system moment about any point, any sense equal to the resultant moment about that point, same sense. Then system moment equal resultant moment about any point, same sense. That's the thing. Therefore, when you find in moment, when you find in line of action of the resultant, so we have to consider about moment theorem. Therefore, the system will be given, then you have to sketch new diagram and mark the resultant on that diagram with respect to that system. Therefore, you take any point, let's say A, then about A anticlockwise sense moment, system moment, you equate to about A anticlockwise sense of the resultant. Therefore, that distance, that means length, that means the line of action of the resultant we can obtain easily. So that's another one specialty here. So if the system of forces can be given different ways, so one type IJ format, Cartesian form. So if the axis system is given, then we can find equation of the line of action. Equation of the line of action. So line of action and equation of line of action, that is two different things. Then to find equation of the line of action, definitely axis system must be given, or if it is not given, you have to take a new axis system that belongs to you. Then you mark axis system, then you resolve positive direction of the x-axis, take x, and resolve positive direction of y-axis, take y, and take about the origin anticlockwise sense moment. Say it is g, anticlockwise sense moment g. Now you know x, y, and g. Then equation of the line of action will be g equal capital Y times simple x minus capital X times simple y. That is the equation of the line of action. And by using coordinate geometry or straight line theorem, again you can find equation of the line of action. So far we know what is resultant. No? So its inclination, let's say alpha, then tan alpha will be the gradient. So now you know gradient, so you find line of action. If you can mark that on y-axis, that the resultant, then you take moment about origin, system moment equate to resultant moment, then you can find y-intercept. After you know y-intercept and you know gradient, you can write equation of the line of action of the resultant. That is very important thing. Then there will be a system given. No? There will be a coplanar system given. So if that force system reduced to a single force, so that can be reduced to three different things. So one is that system can be reduced to a single force. I told it before, no? So then that system can be equivalent to a couple. If the system is equivalent to a couple, then no resultant, but there's moment. If the system is equivalent to a couple, no resultant, but there's moment. If that system in equilibrium, so no resultant, no moment. No resultant, no moment. Then you have to analyze three different things. One is that system can be equivalent to a single force, then R not equal to 0. Then the other thing, the system can be equivalent to a couple, then R0, G not equal 0. Then the other thing, system is in equilibrium. So if it is in equilibrium, then G0 and R0 both must be 0. That's the thing. And there's another thing. So in this, when you are doing this type of coplanar forces question, so if there's mention, if the resultant passing through A, then the given hint will be about A moment is 0. About A moment is 0. If the resultant passing through AB mean about A moment 0, about B moment 0, and any point on that AB line is 0. And also perpendicular component of all the forces to AB, again algebraic sum is 0. Algebraic sum is 0. So there's another special thing. If the resultant parallel to AB mean you have to think perpendicular to AB, then you resolve all forces perpendicular to AB, take algebraic sum, then that must be 0. If the resultant parallel to AB, then perpendicular to that AB, all algebraic sum of the components must be 0. That is a very important thing. And there's another thing. So in this question, you must have same feeling, that is if the system equivalent to a single force and the system equivalent to single force plus couple, both have same meaning. If the system equivalent to a single force mean the system equivalent to single force plus couple, then both case forces, magnitude, direction same, but only thing, line of action will be different. Line of action will be different. So another thing, if a couple is added to a single force, then that single force will be shifted. The single force will be shifted. So if a couple is added to a single force, then that single force will be shifted, then magnitude, direction won't change, only line of action will be changed. If a single force added to another single force, then definitely there will be a new resultant, magnitude, direction and line of action. But if we add a couple to a single force, then magnitude, direction of the resultant won't change, but line of action will be changed. That is really important thing. So in here this case, there can be given, show that the system equivalent to a single force together with a couple at A. Show that the system equivalent to a single force together with a couple at A. So if that is given, then you have to think, you have to find resultant, magnitude and direction usually. Thereafter you take moment about A, and that moment value will be the couple moment. couple moment. Then you identify single force equals single force plus couple. So when you're doing this question, so you have to practice all those things really well. So step by step you have to do this question. So for first segment you have to do it, then after that 10 you have to start new start. You have to get new start with the new addition of the case. Therefore you analyze one by one, then definitely you have to do this question. So again I need to remind you, that is, if you are going to do this question, this is very important. It's easy question to get marks. Then you better to practice all past papers again and again, and you analyze all the questions step by step. Then only you can gain this mark. Okay, so when you're doing questions, you have to follow the things that I have mentioned here, and also you do all past paper questions and you practice it really well. And you must have, again, we must have capacity to resolve forces, and you must have capacity to take in moment. Then that's the thing. Then this is really simple questions. Do this question for your A-level examination. This is really simple and easy question. Then you do this question for your A-level. Okay, then this is question number 14 part B, that belongs to coplanar forces. Then have a nice day.